you to this virtual session of the GPDIS featuring CIMdata's Peter Bilello. Peter will be talking about the digital thread, the PLM Professionals' path to delivering innovation, efficiency, and quality. What I would like to do before we start is to thank our sponsors, ANIC, Kubertech, and Transmagic. This meeting, unfortunately, was supposed to be live. We're very sorry that that didn't happen. It was just over a year ago at GPDIS that CIMdata and GPDIS announced the co-location of a PLM Road Map conference at this year's GPDIS. So what we're doing here is we're actually sharing one of those keynote presentations with you so that you get a flavor, and we hope that we see you next year in Arizona on September the 13th through the 17th. During the presentation, please feel free to add any questions you might have, put them into the chat panel, and then we'll get to as many as we can following the presentation. The presentation will be recorded. Now I would like to hand you over to my colleague and CIMdata's President and CEO, Peter Bilello. Peter, over to you.
Cheryl, thank you very much, and my welcome is with you as well. Good morning, good afternoon, or good evening, depending on where you are. So I'm just a little bit of background about myself. I've been in and around the PLM industry now for 30 years and work on very different aspects of it, working with industrial companies around the world, helping them define strategies, implement strategies, review solutions and others, to look at how do they enable various aspects of their product lifecycle. And this topic around the digital thread is kind of core to it, actually, in a couple of different fashions. So I'm hoping through the next 40 minutes or so of the presentation will give you some ideas of where we see things are at and where we think they should go, and hopefully give you some background or understanding, or maybe confirming what you're already thinking that'll help you better execute the digital thread within your organization. So if you don't know CIMdata, please go look on our website, CIMdata.com, but I'll just give you just a real quick overview here. We are a strategic management consulting firm. We do research, and we actually research, it's over 700 different PLM solutions in the market, but our primary work is with industrial companies. And industrial companies across many different industry groups, from food and beverage companies, aerospace and defense, to automotive, to high-tech electronics, and many others in between, including discussions and work with the financial institutes. So a lot of things I'll say, given my background's also in an industry, but also with working with clients around the world. We see a lot of insight and potential of these technologies to bring more value to industrial organizations. One other thing I'll say about CIMdata consulting, as I said, is our primary work, but it's supported by our educational research services. Again, there's lots of information on our website. Provide some more detail if you would like to take a look at it. But ultimately, what we're trying to do through this webinar and through other activities that we have, our PLM Road Map and the events that we do in partnerships like with GPDIS, is to really deliver strategic advice and counsel through a combination of capabilities that include research, education, and consulting. So hopefully a little bit of a background about me and where I come from. So let me talk about this topic, about the PLM's professionals' path to delivering innovation, efficiency, and quality. And as we look at the digital thread, it's really a multifaceted opportunity. And it can impact various aspects of the business, certainly from an innovation point of view, product innovation, process innovation, creating areas of efficiency that weren't possible before, and then supporting quality and increased quality or higher levels of quality, or maybe more efficient, and the cost of quality could be better as well. So many different aspects of it. Unfortunately, many companies think it's a trade-off between those three. Somehow, like cost, quality, and time to market, it's really a trade-off. There's a three-legged stool, but that's not the case completely, maybe not at all, actually, when it comes to the digital thread, because the digital thread really could have initiatives that are supporting those three aspects, and they can be independent, but they also can be interdependent in that they can support each other. So I'm going to talk about that. It's a pretty important point. So then you don't get stuck saying, well, which one will I do? Well, you could do any of them. You could do all of them. You could do any two of them, and they can be supportive, but they also can be done independently. So we'll talk about that and really hopefully give you an understanding of what we mean by that. We're also looking a little bit about what leading companies are doing, and as they're developing their digital thread implementations and strategies, one of it is to really try to enhance their ability to innovate. Again, product innovation through process innovation. So their innovation platform, being able to enhance that innovation platform. Some of you may have heard me speak before or seen materials from CIMdata published, and some of the solution providers picked up on it as well, that we describe as the product innovation platform. We're also looking for how do you drive that efficiency of development, but not just development. It's not an engineering issue, it's a life cycle issue. So development, production, and service. And of course, as a result of doing this the right way, you're also ensuring compliance, quality compliance on all different levels throughout the life cycle, not just from a design perspective, but also production and delivery perspective. And then finally, I think as PLM professionals, I think probably everyone that is listening in is in some way a PLM professional. We need to understand what are some of the key components and criteria that we need to implement in order to have a successful digital thread strategy, and what are the associated elements to that. What we see a lot of times that companies want to do something, like they say, I want a digital twin, and I want it of the product in the field, but they don't have a digital thread. Well, good luck. That's not going to be very pragmatic or practical for that matter. The digital thread really is an enabler for things like the digital twin. I'll discuss that as well. And often, most of these initiatives require a certain, let's say, foundational set of capabilities. And if you don't have the foundational set of capabilities, then you will not maximize your return on investment. Again, we'll touch on some of those as well in this presentation. And as Cheryl mentioned, if there is any questions, please put them in the chat. If we don't get to them at the end, we will follow up later. So first thing I want to describe is, what are we trying to sew together? So I think about thread, digital thread. What are we trying to sew together? And it's kind of two aspects of it we'll address. Then from there, we'll talk about, okay, so what are you doing? What are you going to do with it? So if I have a digital thread, so what? What's the value? What can I do if I have one? And then how do we get one, basically? And what are those components that I have to take into consideration in order to enable a true digital thread, given that I want to get value out of it? And then I'll have a couple of concluding remarks to remind you what I presented to you. So, for history, for a long time, and maybe some beginning in time in some ways, companies have been stressing about cost, quality, and time to market. And this is kind of the three-legged stool that pretty much all companies want to drive towards, and usually it is interdependent. I can drive down quality or improve quality, but usually it takes me longer and may cost more. I can reduce costs, but maybe I cut corners in quality, but maybe I have to put more process in place and more people in place, which increases costs and so on. So they generally are considered to be interdependent. And I have to look at how do I optimize across the three and do that. And of course, I'm doing that as things get more complex. There's more competition, there are more forms of competition, competitors change, and sometimes they can become partners. We do this on a global scale where we're designing anywhere, building anywhere, maintaining anywhere. So that adds a level of complexity to how I manage my business. Certainly products themselves, as they become more and more smart and connected, I have a lot more complexity I'm dealing with from a product perspective. And I'm trying to drive costs down, but complexity is increasing, and that has to be reconciled, basically. And then finally, there's, of course, ongoing pricing pressures. I don't think there's a customer that wants more capabilities, but it's really necessarily willing to pay a lot more for it. So I still have to do things more efficiently and do it at a cost that is appreciated in the market. So when we look at this and say, okay, so how do I address this in a way that doesn't, let's say, doesn't break the bank, so to speak? Because it really becomes really difficult. We get these small improvements year after year. Many companies are kind of stressed at the point where it's really hard to gain more benefits out of just trying to tweak on these three aspects. So it's really driving a need to look at product and process innovation. And it has to do with, how do I use information? How do I execute my processes and my process flows? How do I develop more insight of what I'm doing and how I'm going to bring that information back from the field to be more innovative in my product? So there's various aspects of product and process innovation that's required to gain improvements. One of the ways to do that is to really enable your end-to-end life cycle, and kind of digital thread is part of that end-to-end enablement, which we'll talk more as we go forward. So thinking about the basic life cycle, what are we really doing as a business? Well, it's actually pretty simple. I create information, or my intellectual property, right? My collective ideas of the organization's employees. That's my intellectual assets. They define the product, they define the processes, they define how things are going to be built, how they're going to be manufactured, assembled and serviced. So it's a whole set of information. And then as I create that, I then transform it, I execute upon it, and I deliver the product and processes the products and services to the market. So at the end of the day, what I deliver to the market is a result of that information set. That's actually the life cycle. It goes from creation of intellectual assets, goes transformation into the deliverable assets. That's really a simple way of looking at it. It's very accurate, and it's connected. Well, it should be connected. Most companies, it's not very well connected, and you don't really have a digital thread. It's more like a digital disconnections that exist throughout. Sometimes those digital disconnections have paper in between. Sometimes I have manual intervention that has to take place. Other times, if you're more fortunate, there's integrations. But it's not as streamlined as it should be. Because it's really important to do this, because if you look at innovation, product and process innovation, it generally does not take place just during the transformation of that information from the virtual space to the physical space. It actually has to start with the foundation of those intellectual assets to begin with. Because again, at the end of the day, your product and services is the outcome of that information. That information isn't valid, isn't complete, isn't accurate, then what you deliver is not going to be, it's not going to be very efficient in how you deliver it or how you support it. So that's why the end-to-end connectivity from concept through life is so critical. And this is, for some reason, I see a lot of management and CXOs and that kind of forget that it's not the fact that you're producing something, it's the fact that you've designed or have a design to produce something. Because your production, when you're buying materials and getting sales from those materials and ultimately from the services, is a result of all that information that goes before it. So if I'm not managing that information and the life cycle of that information, having it connected, sewing the thread, then I'm going to have disconnects. And that's where a lot of inefficiencies come in and makes it more difficult to have compliance and have the right levels of innovation that are possible through my product and processes. So one of the ways that we've kind of drawn this life cycle for years is showing it as a swoosh where information is connected from requirements all the way through life. So life could be not just recycling, it could be remanufacturing, recovering, and so on. And that's really painting a picture, and we've been showing this for, well, at least a decade or two, probably 2 or 3 decades for that matter, is this end-to-end connectivity. This information flow does start at requirements. Let's say you have something in the field and you want to make a change to it or make a major upgrade to it. Is it compliant? Compliant to what? Well, compliant to what it's configured today, but also compliant to what it was designed to do. So it's connectivity from end to end, and bidirectional connectivity is what we've always been after. And like I said, I've been in the PLM industry, what we call today the PLM industry, for about 30 years, and nothing's changed really in the concept. Our ability to execute or enable that concept has changed quite a bit. Maybe our willingness to do some of the hard work has changed, but quite frankly, I still see a lot of companies missing the mark because it's easier, or maybe it's more straightforward for people to understand I have to pay people, I have to buy things, than it is I have to create product information and process information so that I can actually exist as a company. Now, I'm somewhat sarcastic in that, because the reality is I don't make money, I won't pay people if I don't have a product or service to sell. So really at the foundation is my product information, ultimately, and the people are part of that, and then the people get paid and finances are needed to go buy things. So if we had that priority, maybe we'd put some more effort on this, but it is also a little bit more complex, and that's one of the reasons why these things generally aren't as robust as they could, and that's why we have to paint and show what the value is to have this end-to-end connectivity. And you think about the life cycle itself, I'm sure you all have this very good understanding, is I have different sets of information or models in the model-based enterprise view of things that describe various aspects of the product, or there's other models besides that. There could be financial models and so on. But I have requirements models, I have as simulated, as designed, as installed, as delivered, and so on, which are various representations of the product information set. Generally, CIMdata describes that as the bill of information, and then you can have virtual logical representations of that depending on where you are in the life cycle. And you can think of some of these representations, well, they're all virtual representations, and some of them are digital twins. Once there's something that's physical, you can then have a digital twin of it. And again, this connectivity is really important because the as planned is a result of the as maintained, which is, as designed, which is, comes from the as simulated and from the requirements, and is as built, needs to trace itself all the way back to requirements and so on. So here's an example of that. This one, I believe, actually something that, and it should be annotated here, unfortunately, you probably missed that, comes from a picture we had seen some years ago. I think PTC actually originally developed this, or a picture similar to this, where you have connections from the planning phase all the way through service. You want to have traceability of the various aspects of it, so your as required twin, so to speak, or virtual representation, moving down into your as conceived twin, or your logical structure or system structures into engineering structures, your as designed twins into your simulation structures that may be the validated twins, manufacturing productions, production, the manufacturing structures, your as built twin, and then finally your as maintained view or your as supported twin. So this is a pretty common concept, and again, I'm showing a link between the various aspects of those representations from one to all the way through the life cycle. So this is one way of thinking about the twin and the linkage of them around the digital thread. And what we want to have is this bidirectional connectivity. It's just not just end-to-end, but bidirectional. So I have closed loop impact analysis and traceability of changes as an example. So those are some of the reasons why you want to have this connection, is to be able to do closed loop impact assessment and traceability of changes. And that could be a change that's forced upon you and like a regulatory requirement that changes, or it could be a change that you want to put in for a new feature. And the flow is often not linear and could loop back in many different ways. And you want to have that connection so that you can receive value from the insight that you gain at different points in the life cycle. So what are we sewing? Let's look at this a little bit more detail here, because I see it as kind of two aspects we're sewing. The first one is sewing together the definition. So we have a set of functional domains that are developing out various aspects of the design. Depending, especially smart connected devices, we have software usually, we got electronics and mechanics, there's system architectures, there's requirements, there's modeling and simulation, verification and validation and testing. And I need to sew together those various domains, from a model-based systems engineering perspective in order to optimize what that product is. How will I break down the requirements? What capability will I deliver that through? And software capability versus electronic capability and so on. So that's one aspect of a digital thread. It's not the whole life cycle. This is more the thread of the design elements. As I said, I believe there's two kind of digital threads. Now, there are some issues with this. We have a lot of technologies that come from multiple solution providers, and there's issues around tool integration and data interoperability. And interoperability is pretty important if we're going to share information and have this bidirectional communication both within or across my disciplines, my engineering disciplines, for example, or throughout all the disciplines in the organization for the life cycle. I want to be able to share information in a way that people have the same understanding. It has the same context or understanding of the context. So taxonomy, structures and information need to be defined in a way that everyone can have the same understanding. And there's issues about tools that store in different formats. That's where data standards come in. A lot of ISO standards and other standards that are out there that can support some of this. And we're still kind of driving towards this world where interoperability is king. It's certainly required and has been worked on for decades, but there's still a lot of gaps in the process. In some ways, there's too many standards, and another way, it's great to have standards, but we still have to figure out which standards are going to work the best and be able to get behind them as organizations, and then also request our solution providers to support them as well. So here's some of the standards that are out there, and just some of them. We did a study a few years ago in the A&D space of all the different quote PLM related standards, and there was over 200 of them. But here's some of the data linking and interoperability standards. They're kind of more related to model-based systems engineering. I'm sure many of you, these are very familiar. There's a lot of work going on in a number of the different ones here. Some of them are much more robust than others, and some are being used more than others. But you know, the focus should be as an organization is what are the standards that I should support? How does that impact my design or my value chain? And then which ones will my solution provider support, or which ones should I ask them or tell them, contractually tell them to support, so that I can weave a digital thread throughout my design aspects of my product information. So again, that's the first aspect, kind of building this out then, and building it out not just from a product development point of view, but a true life cycle point of view, so that I have the development aspects of it connected, but also the execution side of it as well. That's where I get the life cycle aspect of the digital thread. So again, we have one of it is sewing through the different disciplines and then connecting that throughout the whole life cycle. So I make a change to something in the field. Am I changing electronic component, a software component, a mechanical component? Maybe it's a documentation component I'm changing. So I want connectivity back to the disciplines. And if I'm really doing true systems engineering, I'm doing it across not just engineering disciplines, but all the disciplines that optimize the product. And what I mean by that is, if I'm going to truly optimize the product and optimize the product lifecycle, I'm also going to look at, well, where should I build this product? And what's my logistics for it? What's my production facilities and capabilities for it? Because ultimately, I want to optimize the full end-to-end lifecycle, and it's another aspect of the digital thread. That end-to-end connectivity allows me to understand the different aspects of how that product will be not just designed, but how will it be produced, serviced, and brought out, you know, commissioned, brought out of life cycle for that matter, decommissioned, for example. So I have to take consideration of all those different aspects to truly have a model-based enterprise that I can use to optimize my product and services. So here's the definition that CIMdata uses for digital thread. We talk about it as a communication framework, and that connects data flows, which can be used to produce an integrated and holistic view of an asset's data from physical and virtual systems. So that's the digital twin, which I'll mention or give you our definition of that in a minute, throughout its life cycle across traditionally siloed functional perspectives. And certainly a digital thread is an enabler for the end-to-end connectivity and connected systems models that we require within the model-based world. And then, so talking about the digital connectivity of the thread, you know, the good news is there's a lot of technologies out there that support it. Now, I'm not saying these are just 4 examples from 4 different, you know, pretty popular and well-executing solution providers out there, and many of you probably know them or have at least one of these technologies within your organization. They've all done, 4 of these, excuse me, have done very well in the aerospace and defense industry, for example. And they all just show this. I mean, this is not specifically their technology, but what their technology can enable. And certainly in our work, we've seen all 4 of these and others support various aspects of digital thread for the life cycle. And so that's great. We have the technology, but what are we going to do with it? So why should we care about the digital thread? Now, I get this asked sometimes by a CEO, and they said, well, I want to have a digital thread, and I ask them why. And they said, well, usually they don't really know. They may make something up, which I won't try to make something up for them, but they don't really actually know. They want a digital twin, but they may or may not know what that is. Usually that's better, well, I wouldn't say well understood, but better understood than digital thread. And a lot of times there's a disconnect. They don't really understand that to really truly have a digital twin, which is represents the physical thing. You have to have some form of connection. It could be manual, but it still has to be some form of connection. And having a digital thread that feeds it is pretty critical to be efficient and effective and then drive innovation. That is usually not very well understood. So, okay, so what are we going to do with it? All right, well, imagine what you could do if you had a digital thread that provided this end-to-end connectivity. What would that mean? Again, in a way that's effective and efficient. I'm not necessarily saying it's one solution. Maybe it's a platform, there's multiple applications, but it's connected. You know, it could be, let's say logically speaking at least, that we have this end-to-end connectivity. Think about it. What could you do? What better capabilities could you provide to the market? What better services you could provide? How would that help you in manufacturing? How would that help you in requirements gathering, for that matter? So again, a life cycle issue. So how would it support various aspects of the life cycle? I will share you some of my thoughts of what that looks like and some of CIMdata's thoughts on that in a minute. So again, imagine what could you do if the digital thread tied together the virtual and the physical worlds. And you may be familiar with the Boeing MBE diamond symbol here, which I think it does a really great job of kind of bringing a bunch of things together around models, from the physical systems to the digital twins, and you can see in the core there the digital thread connecting it all together. So what could you do if you had this connectivity that goes multiple directions between design and models and simulations and delivery, from design to delivery and models to simulation and so on? Pretty powerful if you had this information and the connectivity of this information to make better decisions, to do them more quickly, again, be more efficient, to be more innovative, to be more compliant, and certainly different aspects of that depending on how you implement it. Well, imagine what you could do if your project information was always accurate and complete throughout the entire life cycle. So this point here, this comes from the CMI, originally from Institute of Configuration Management, now part of IPX. They talk about the integrity of information and the effectiveness of the organization, that they're linked. There's a direct relationship. So the more accurate and complete your information, that's average integrity here, the more effective the company. So think about it for a second. So if I'm, like most people do in companies, I make decisions based on information. That if information is inaccurate, I'm going to make probably bad decisions. If it's incomplete, I'm going to guess or I'm going to wait. Both of those things add to inefficiency. So most companies actually are probably only 40 to 50% effective ultimately, because they don't know what's complete. They don't know what's accurate. So they put in processes that take more time. They put in processes to get more signatures, get more reviews. Those are inefficiencies. But we do that because we're guarding against making decisions on incorrect or incomplete information, so that we can drive it. Just for example here, from 90% average integrity to 95%, we go from about 42% effectiveness to almost 68%. Pretty significant. But I need both. I need completeness and accuracy. It may not be complete to start with. We build out information set throughout the life cycle. So then in that case, we have to understand what's there and what's not there, so that we can make better decisions on the information set that actually is accurate. We want to guarantee that accuracy as well. So now let's talk about, one of the things you could do is enable a digital twin or multiple digital twins. So I'll talk about that in a second. So we have here, the digital twin, as we describe it, as a virtual representation. It's a digital surrogate, or some people talk about it as a digital avatar of physical assets or collection of physical assets. And it's going to have to really be valuable, exploit the data flow to and from the physical asset. Again, can be a very important part of a model-based system engineering, both of product and processes, including production. So again, multiple twins. So let me talk about that a little bit. So in our view, agree with the work that Assess has done, that there's never one digital twin. There's different digital twins. There can be an analytical digital twin, MRO digital twins, financial digital twins, engineering digital twins, engineering simulation digital twins, and so on. And to be a, quote, digital twin, you have to have something physical. So generally speaking, you have a virtual representation that starts at the beginning, but they move out through the process. And once you start having, let's say, prototypes, then you, quote, then it would technically be a digital twin. But there can be different forms of that digital twin, of course. And to be a twin, you have to make sure that they represent each other. So if I make a change in the virtual, I have to make sure that change is represented, or my closed loop of the change in the field to whatever that physical thing is. And if I make a change in the field, I have to make sure that's communicated back to the digital twin, so that the virtual is equal to the digital and vice versa. And that doesn't mean it has to be electronic connection, but certainly in the age of smart and connected everything, IIoT and IoT, that's more possible, more pragmatic today, I guess, or more practical to actually execute. So you can also enable a robust MBSE environment. So I'm just using kind of more traditional systems engineering V here. But think about the connection I can have, back and forth here, not just all the way at the digital twin, but I have this thread that weaves its way through the design, but continues through the execution of it and back around. So here's my life cycle, and the thread connects that life cycle so that I can do this in a much more efficient and effective manner. Again, be more productive and be more compliant by being able to have this connection from start to finish. Be able to do the verification and validation in a way that's much more efficient than I could do it before when I had a lot of disconnects, at least logical disconnects, if not, well, probably a lot of physical disconnects, hopefully not logical disconnects. But we really need to have those things connected logically at a minimum so that we can actually improve the effectiveness of the way we execute the product lifecycle. So this is the other thing, you could also do a lot of other things that support product and process innovation, efficiency, and quality. And look at this connection here. This is, looking at connecting the life cycle, and of course, IoT and other things can be used to do that connection, especially in the field, but we're not just supporting a digital twin in the field. Bringing information back and connecting it all through a digital thread. What kind of insights can I gain from things in the field? What about back to concept and detailed design? So robust architectural concepts and detailed design based on actual user usage information. So bringing that information back from the field, bringing it back from production, bringing it back from other areas of the business, not just from a design perspective, but a life cycle perspective. We get testing as well. Prototype system performance monitoring, providing grounds and testing lab monitoring, and connecting out the various aspects of the life cycle that provides me feedback so that, again, I can improve my processes, my products, which I gain efficiency and get a higher level of quality and compliance. Back to manufacturing again, closing loops there, and then after sales and service. So you can think of this as the life cycle flows from left to right on the slide. I continue to provide feedback that can go from any stage back to any other stage. If I have a digital thread, a logical digital thread that provides that bi-directional connectivity, if I don't have it, and we've struggled this for years, not having it in many organizations, I do it maybe hit and miss at times through some kind of program that I go evaluate all my warranty claims, try to figure something out about it. But it's generally hit and miss programs, not a full connected process, which enables me to be more innovative in how I execute product lifecycle. So just drill down on that slide a little bit. There's companies we work with, there's tens of millions, hundreds of millions of value that can be extracted out of that if that digital thread is implemented in a way that has the right level of connectivity, the right information flow, and that bidirectional nature that's required. And the insights that can be gained throughout the life cycle can provide incredible value to the organization. So how do we do that then? What are some of the practical aspects of it? Because it is a multifaceted opportunity. And we look at it, again, it's not just about innovation, it's not just about efficiency gain or productivity improvements or quality improvements. They're all important, but you can attack different aspects of it. When we look at the leaders in this industry, industry application of digital thread, we're seeing a lot of development of strategies around the digital thread, sometimes disconnected, by the way, from digital initiatives or digital transformation initiatives. Because again, the digital thread is the underpinning by which we're connecting the different disciplines that are developing and optimizing the product and services from a lifecycle perspective. And as we look at that, then I can go drive innovation through my innovation platform. This could be at the enterprise level of how I drive innovation. Where do I invest my money? And how do I make sure that I'm optimizing my return on investment from a lifecycle perspective? And the results then can include efficiency of development, but also production and service, because I'm optimizing across the digital thread, not just in engineering or not just in production or not just in service. And of course, as a result of that, I can develop and adhere to higher levels of quality as well, because I have a full picture of the life cycle, and I'm developing quality from a life cycle perspective, not just some domain, engineering domain, or just from a product development perspective. And that's why I kind of look at this as there's some, they can be, and I think they get value. There's interdependency between the three, but they really are independent, because I can drive innovation, and then that can result in efficiency gains. It can result in more quality. So it's not a matter of where do I tweak it? Do I tweak it here in efficiency, tweak it in quality, tweak it in innovation? No, I drive an improvement across the life cycle, which allows me to optimize my return on investment. That's really what I should be focusing on, not that these are interrelated somehow, that I have to get the right balance between the three. Reality is, if I drive innovation in my product and processes, then I'm going to gain efficiency and gain quality. But I may have quality initiatives that can drive back in innovation and efficiency and so on. So while they're independent, there can be some interdependency and imperatives, improvements that can provide an additional value when you look at it in an organization. But it's not the cost, quality, and time to market equation. So I don't want anyone to think about that. Well, you can think about cost, quality, and time to market, but it's about product and process innovation that drives things, which really is where I gain my value of these major imperatives of innovation, efficiency, and quality. And so the development and resulting value then from having a digital thread initiative, does require a multifaceted approach. And it has to be ongoing, and it has to require not just, and include not just the technology aspects of it, but people and processes. This is, again, where I see a lot of companies fail to gain the value that's possible, is they'll say, well, I want a digital thread, or I want a digital twin, or I want this digital transformation to happen, but they forget about transforming the people's skills. They forget about adjusting processes accordingly to take advantage of the new technologies or the new skills, and vice versa. So those three are really important, and they have to be done together. And that's where you're going to optimize the return on investment ultimately. So if you think about it, ultimately, if the digital thread is your desired end state, what are the elements that you must consider to achieve it? That's the question, so I'll answer that on the next slide here. Here's kind of a set of selected enabling elements. And as CIMdata's work, we see these as key to end-to-end digital thread enablement that you can't and you shouldn't really live without. One is the data. So if the thread is tying together disciplines and information sets, you better have data and process management. If you don't, then will your data be valid? Will it be complete? Do you have the right levels of integrity or not? You have to be able to manage structures of information, models of information, so that you're bringing the information in the right context, the right understanding to the people, whoever they need it, wherever they are in the life cycle itself. And that means it's under control. It's under configuration control, so you understand what is the current version of information, what's been released, what is the configuration of it in manufacturing, what was built, what was installed, what's being maintained. And being able to connect that together as best as possible. Some of that may be through IoT into the manufacturing facilities, maybe it's IoT, or maybe there's still manual processes that are required. But you won't have a digital thread if it's not connected in some way. It can be a logical digital thread. It doesn't have to be physically one system, but you have to have that connectivity, or you don't have technically a digital thread. You may have a thread, but it's just not digital. And then that connection into that representative data set becomes that digital thread, the digital twin, as I mentioned earlier. You also look at this, and if I have a digital thread, what can I do with it? The information, right? This closed loop, providing insight. That means that information becomes as powerful and maybe more powerful than the product itself. And in some areas, the information is becoming the product. The product is not being sold, it's being delivered because of the information that comes off the product. Or it could be just product as a service. That means I need to have a better understanding of the product and how it's performing so that I can be as proactive as possible in making sure that that product is always executing when the customer wants it to execute. And that again gets into better understanding the data. So big data and analytics becomes critical. Now, how do I gain insight if I don't understand the data itself? And we've seen this a lot where companies are gathering petabytes of data, terabytes, petabytes of data, but they don't create any insight out of it. They just gather more data, and you lose the opportunity. And that gets into then what data should I gather? How will I manage that data? So that gets into data governance. If I'm running on data and that digital thread that is information, it's data, I have to have governance over it. So where is it owned? What systems owns it? Does the system ownership change over time? And that's one way of just describing and making sure that digital thread is maintained from concept through life. And then finally, I have to be able to change the way I work. That's the processes and skills. So the digital skills transformation is critical as well to really take advantage of the digital thread. And I'm sure you've all seen this before where you get a new technology and people are really excited by it, but then they're not, well, they may be trained in how to use it, but they're not educated in why they should use it. They're not really skilled to use it. They're just trained to use it in one way or another, but not fully on why it should be different in the way we use it. So we try to kind of use the new tool in the old way. And just think about this for a second. How many of you have been trained really to understand the current version of, let's just say, Microsoft Word or Excel? Maybe you've received some training in the past, but do you have the newest training that knows the newest features? Now with 365, I would say we get these upgrades every so often that kind of describe the new features, and I'd say I probably have used none of them because we not keen on it. We know what we know, and we're happy with it. It gets the work done, but there's a lot more capabilities out there that we could take advantage of. That's true with any kind of transformation. So last thing before we open it up for some questions, just a couple of concluding remarks here. So as PLM professionals, we can deliver innovation, we can deliver efficiency, and we can deliver quality through the digital thread. And enabling this is a multifaceted effort. It requires multiple organizations. If we're really going to have a truly end-to-end digital thread that covers the life cycle, we can certainly start with an engineering and sew together the various digital aspects of the product development, in the more the model-based system engineering world. But if we really want to get to a model-based enterprise, and that requires an end-to-end optimization, and then that's going to drive initiatives around innovation, efficiency, and quality. Some efficiencies could come out of those other initiatives, but together they can provide a lot of value, but they can also provide value to individually, and they shouldn't be looked at as interdependent, but independent, but actually can support each other. They could be supported aspects. So it really requires a robust of independent as well as interdependent initiatives and improvements to drive the value in your organization. And there's a lot of companies out there that are driving strategies and implementing various aspects of the digital thread. It's not all or nothing. There's usually some good starting points, but you can then develop that over time so that you can enhance your innovation platform, especially your product innovation platform, maybe your greater enterprise innovation platform, where as a result of doing this correctly, you're driving your efficiencies for development, for production, for service, and at the same time ensuring and enhancing your ability to ensure compliance. And ultimately, it may allow you to rethink and can allow you to rethink what your products are and how you deliver them, moving more towards a digital space where your products become something that delivers information, which then you can provide feedback not only to your customer and to service aspects, but all the way back to production, development, and other areas of your own business. And then finally, I think it's all up to all of us as PLM professionals to understand this, to be able to articulate in a way that allows companies to understand the value of the infrastructure that the digital thread provides. Now, a lot of management is not particularly happy paying for infrastructure, but they do it all the time. You build a new facility, you're paying money to put water in, to put power in, and those things are worthless if they're not used. A digital thread is worthless if it's not used, but in itself is an infrastructure component when you think about it. It's a way of tying information flows together like the pipeline of information, and that core backbone of the PLM is ultimately that data and process management backbone that the digital thread rides on or is part of. And it requires then a change in the way we think at times, the way our products are, and ultimately the people, process, and technology aspects. So I hope this gives you some maybe additional insight and why these things are important. I do want to mention we'll be expanding on this. We had, as Cheryl had said, we plan and we'll certainly, if all goes well, next year be part of GPDIS and have the PLM Road Map within a version of it within GPDIS. We have had an opportunity to go ahead and do a virtual event as well. We're doing in November. You can see the information here. Go on our website. There's going to be, because you participate today, we're certainly happy to offer you a special offer if you sign up in the next week or so. There's quite a number of industrial people that are going to be presenting at this event. A number of them are going to be from the CIMdata facilitated Aerospace and Defense PLM Action Group, the ADP PAG. And 4 of the work streams that are undergoing right now, or underway, excuse me, are going to be reporting out. And you can see them. And there are certainly aspects of these things are all important for the digital thread. Actually, I would say probably all 4 of them are, because builds and materials are within it. Collaboration is part of it. MBSE, data interoperability, we spoke to, and of course, model-based definition as well. So I hope we'll see you there and you'll participate in that. I'll open it up for some questions now, and I'll see how much we can address in the next 15 minutes or so. Cheryl, do we have any questions?
Yes, you do, Peter. Hopefully you can hear me.
I can.
Great, that's good. Got the right button. Okay, let's go to the chat. And first question, Peter, is you mentioned Aras, Dassault, Siemens, and PTC. Does Simulink play into the digital thread?
I'm sorry, I missed about, does what simulate?
Does Simulink?
Oh, Simulink. So it can be an enabler for aspects of the digital thread, certainly. It's, in itself probably wouldn't provide everything, but it depends a lot about what you're trying to connect in the digital thread, and it certainly definitely has capabilities, and we've seen it play a part in enabling a digital thread.
Great,
and as I said on that slide, I should just reemphasize it, is those are just 4 examples. CIMdata tracks about 700 different solution providers in the market, and there's a lot more than the 4 that are providing capabilities that support the digital thread.
Thank you, Peter. Quite a few people have asked this, and I can answer it. Are these slides be available? Yes, they are, and I believe there's also going to be a replay of the presentation. But if they don't make their way to you, please don't hesitate to send me an email to c.peck@cimdata.com. I'd love to. I can always share them with you. Okay, the next presentation. Let's see. Okay, is the assumption that the digital thread is an idea, or is there an assumption that digital thread is enabled by true system and data connections and flows as business processes are executed?
That's an interesting question. I would have to say both. It's certainly a concept or an idea to start with, is to have, again, end-to-end connectivity of information flow. So conceptually thinking, if you conceptually think about the product life cycle, I start with some concept of a product or a service, or product and or service, and then that grows over time and evolves into a definition. Part of that definition is a bill of material, but it's much more than that, right? There's simulations, there's input data, output data, definition around how it's going to be manufactured, assembled, how it's going to be supported. So this information over time grows as it goes from concept through life. So conceptually, that's the concept. There's reality to that as well. I mean, that's what happens. But also what happens is usually there's disconnect and at best handoffs of parts of that information set. So in that way, it's a concept because it's not fully implemented. I don't know of one company that really truly has a full digital thread in a way that would say it's a whole model-based enterprise, but there's many that are driving towards that though. So then you go to the other aspect, is it something that can be physically implemented? The answer is yes. Again, there's some examples out there. May not be a full digital enterprise yet, but there's some good examples from a product perspective and a product enablement point of view where a digital thread has been enabled from concept through life. So in that case, it's real. Sometimes there's handoff, but automated handoff, maybe to ERP, for example. And I've seen some cases for a number of years now where the digital thread is throughout the PLM environment into product development and then releases the bill of material to manufacturing. Manufacturing then releases the as-built view back to PLM and the MRO component of it, maintenance, repair, and overhaul component of it, or the equipment asset management solution, which then continues that digital thread. So in that case, there's a logical and physical digital thread, just happens to be across a couple of different solutions. So I would definitely say both. For most companies, it's more theoretical than physical, but moving more and more to physical in lots of different industries.
Thanks, Peter. The next question we have is, I think of digital thread as traceability. Is that a way of thinking about it?
Well, it goes back to comment about forwards and backwards, bidirectional traceability, right? If I make a change, if we're going to make a change anywhere in the life cycle of something, well, this is something, and if you guys know CM2, you don't change a physical part. You change the information that results in a change to the part. So I'm always thinking about it that way, is that I have to go back to the information. The information is what I'm managing, and then the information results in doing something, results in manufacturing something, buying something, assembling something, maintaining something. So that connection needs to be always there.
Thanks, Peter. The next question is actually going to be 2 parts connected to each other. There was a little bit of a postscript to the first part of the question.
Okay.
Okay. With respect to systems, MBD, model-based design, part of the digital thread, if the MBD models are not part of the digital thread, then I would say we have an incomplete digital thread, i.e. those MBD models that are modeled in tools like Simulink. Maybe, just asking for a comment on that as opposed to a full question.
Yeah, so again, I said this before about, there's the concept, the logical digital thread, and then how do you physically implement it? And it's not, logically, if you're really going to have a digital thread, it needs to be connected. But it doesn't have to be a singular, instance, so to speak, of that information set. But it better be logically a single. So if I'm looking at it as a user, I understand it logically and I can see the flow. But physically, it could be separated. So yeah, you could have Simulink within the environment of a digital thread, depending how you integrate it into your processes and your data structure. It could be logically part of the digital thread. I would say, it may not, may or may not be worthwhile doing that, but it's certainly possible to have that done. And so, and I would agree with the comment that, and I said this before about the structures and certainly model-based definition structure is part of the information structures that are part of the digital thread. And if it's not, then you probably don't have a digital thread, at least not from a product lifecycle perspective.
Okay, Peter, thank you so much. I've had a couple of private questions sent to me, and the first one of those is, how important are interoperability standards to the realization of digital thread value?
Incredibly important. I would say at a scale 1 to 10, 10 being most important, it's like a 12. And this is one of the difficulties in software industries, and you're going to have heterogeneous environments. I mean, the odds of you having all your solutions from one solution provider, first of all, I don't think it even should be a dream. There's too much specialization, and to think that one solution provider can provide everything is probably unrealistic. Some can provide more than others, certainly, but when it comes down to it, there's stuff that even you're going to even develop. I'm just thinking simple things like simulation codes and other things. So that means I'm going to have data that has to be moved back and forth in one aspect or another. So interoperability between solutions you have, solutions you've customized, and third-party solutions that you have all over the place are going to play and continue to play a very important role. Now, one of the things that I mentioned briefly about a couple of times, the innovation platform. And the way CIMdata describes product lifecycle management, we describe it as being enabled by a product innovation platform. And that product innovation platform, at the core of it, is the product and process data management backbone. That's where the digital thread lives. And we describe it as a platform in the same way an iPhone is a platform, or a smartphone in general is a platform. It's a platform in that it's a hardware platform and an operating system platform. And then the last time I had seen, there's over 1 million applications that can sit on an iPhone platform. And they can all kind of be upgraded individually, right? I can get new applications and I can upgrade the operating system separately, which then can drive upgrades to my applications. I can get a new phone, and pretty much one thing that's been nice about the smartphone revolution is that you can pretty much upgrade nowadays without worrying about losing stuff. And then those applications have access to core data. So, in the smartphone world, the core data around people, basically your contacts, the camera, cellular services, and so on, that you have access through applications which are made by many different third parties, literally like 1 million different applications out there. That's where the innovation platforms and the enablement of the product lifecycle really needs to go. And we've been kind of preaching this platformization of PLM now for, 6-7 years or at least. And we are seeing that. I mean, you have some really good examples out in the market. The solution providers, especially the major ones, are driving that. And to be able to be innovation platforms and be open, we would hope as well. And that's one of the characteristics of a good innovation platform, is that it's open, because again, there's going to be applications that you're going to have to plug in, and hopefully there'll be more of a plug and play. So all that kind of fundamental, all of that then is to being able to move information. And if there's not interoperability of information between those different applications and the platform, then you're not going to be able to connect. And then we get into standards. So we have different forms of data, model data, and when I say model, like geometric model data versus information models, like a product structure, for example. Those are all needing standards as well. There's a lot of good work going on there, and some of the AP stuff I follow, like 242, 239, and others that are driving that. There's a lot of SysML standards and others around different types of models, and I really hope, and I know in the PLM Action Group, the A&D Action Group, there's work being done there to kind of promote certain standards, not the great new ones, but to, as a group, a major leading A&D companies to drive together to common standards or common agreement of what standards will be core to all those organizations. So I'm a big proponent of it. I really see interoperability being a key to enabling ultimately the digital thread.
Okay, Peter, thanks for that. We have time for one last question, and again, it's one of those that was sent to me privately, but it seems very appropriate given that we have an A&D based audience. Where would you see the biggest value of the digital thread in the A&D industry?
Excellent question. Unfortunately, it varies. It varies to kind of what kind of program are you dealing with. And defense programs, for example, tend to have different life cycles. If you're dealing with a major ship system, you could be talking about 50 or 100 to 100 years in an aircraft carrier. If I'm dealing with a submarine, it's 30, 40, 50 years. Aircraft programs, and of course some that weren't designed to last so long, but like the B-52 has lasted a whole lot longer. So the programs tend to be very long. So a lot of the value, there's definitely value during product development, but a lot of the value is going to be, because of the long life, will be more probably after sales type and service aspects of it. On the commercial side, though, it could be more so in feedback from manufacturing, bringing that back into product development and so on for continuous improvement. For refining the products themselves, understanding what's going on in the field. So it tends to be a little bit more rapid change, but not compared to consumer packaged goods, of course, where they have cycles of like 3 to 6 months. We're still talking years, but we're not talking maybe many decades. So it will vary some, and I can see it really all along from that concept development and understanding what's going on in product development and getting feedback, but also then changes that take place when production and certainly after sales and service as well. So I'm hoping that gives you guys some additional insight there. And Cheryl, I think that's the time.
Yeah, there are a lot of questions. So those we don't get to, we'll address them after this in email from Peter or some other way. But we'll definitely get back to you. And we thank you for those questions. They were great questions. Before I hand this back to Peter, I would just like to say thanks to GPDIS, the executive and the planning committee. Everybody's done a lot of hard work bringing this series, this sessions to you, and I very much appreciate what they've done. The next thing is that we still have more to come. So the next one is David Odenthal, who's from Boeing, and he'll be talking about manufacturing data standards. And you can tune in for that on Tuesday, November the 10th at the same time. Peter, now, if you'd like to say a few final words.
Sure, thanks, Cheryl. I would like to also extend my thanks to GPDIS. The partnership is very important to us. We consider it strategic. Also, thank everyone for participating today in the questions. I really appreciate that. It means people are listening, and you're passionate about it, and I'm certainly passionate as well. So I appreciate that, and please reach out, ask more questions, and happy to respond to you, and we'll certainly get to the questions I asked. We wish everyone a good day, and we hope everyone stays healthy. Thank you very much.
That ends the session. Thank you.